Hello, hello. So, to study statistics, one important basic underlying assumption that you should know is the basic probability theory. That is inferential statistics. Remember, descriptive statistics and inferential statistics. Descriptive statistics is your mean, median, mode, your standard deviation. All of that is used to describe the characteristics of whatever group you are studying. Your sample may be 200 people, 300 people, 500 people. Now, when you get into inferential statistics, the whole game is different. Now, you do not just want to know about that small group. Depending on that small group, you want to see whether my findings from that small group apply to the larger population. Can I generalize the findings that I got from this 500 people to say 5 lakh people, my whole population, all teenagers in Karnataka? Now, that is what we call as inferential statistics. And to do that, the basic mathematical assumption of all of that is this basic probability theory, which is important to learn. So that is where I always say, before you learn t-test, chi-square, ANOVA, all of those heavyweight statistical tests, it is always good to learn basic statistical theory, or else everything would be just, you'll just memorize these statistical tests. It will never be of use to you. Now, in real life, what do you mean by probability? I would say it is as simple as managing or measuring uncertainty. See, in real life, how sure are you that some event would happen? Would it rain tonight? Would some political leader come here tonight? What would happen in Iran? How would the war, would the Strait of Hormuz be closed or opened? How sure are you of some event to happen? Are you 100% sure that it will happen? Or are you 0% sure that it will not happen? I hope you get the idea. We are rarely 100% sure. Now, probability helps you put this in terms of numbers into mathematics. How likely, what percent is it likely to happen? So, in a way, probability is a scientific way of dealing with uncertainty, turning it into numbers. Now, 0% possibility, it is impossible that something would happen. Your probability is 0, and 100% your probability is 1. So your probability values will always range from 0 to 1. Now, see, this is just like the mean that you calculated. Remember, total sum of 10 students in a class divided by total number 10. You get the average score of that class, right? Similarly, this is one equation. Even if it is a theoretical question, please write this in the exam paper. The probability of some event happening is the number of favorable outcomes divided by total number of possible outcomes, all outcomes, the specific event that you're looking for. Suppose if it is a coin flip, heads, what are the chances of heads occurring, and what are the chances of all the outcomes? If it is a coin flip, it can only be head or tails, right? So the all possible outcomes are 2, and you are looking for one outcome. Heads coming in a coin flip is only one outcome. I hope you got it. It will be 1 by 2 if it is a coin flip. I hope you get the idea. Now, same thing that I was saying. If it is a coin flip, you are looking for heads. Uh, that is one outcome. How many total outcomes are there? In a coin flip, only heads or tails can come, right? More than that, no other outcome is there. So that is why your probability is 0.5 or 50%. Now, always remember, this does not mean that you will get heads every second time you flip the coin. This time I got head, next time it will be tails, next time it will be head. No guarantee like that. Probability does not mean that. Probability actually means the chances of something occurring in the longer run. Okay, that is what we mean by that. Anything which is unpredictable, if you take a look at it over 100 times, 500 times, 1000 times, you will be able to see some pattern. That is what probability means. Now we are going to put that pattern into mathematics. So in a way, probability is predicting patterns over repeated trials. Probability in the longer run, not predicting the next single event. That is not what probability means. So that is why if you look at just one coin toss, it might be we are not sure what would come next. But if I look at the next 100 coin tosses, there are very good chance that 50, mostly 50 would be heads, 50 would be tails, but this can change. So if I'm looking at a single outcome, yes, it is a simple event. But what if I'm looking at a compound event or multiple outcomes? Like a single outcome would be, what are the chances if I roll a die? This is called a die. We all know we've played Ludo, right? What are the chances of the number 6 occurring? It's a single event outcome. Now, what are the chances of even numbers occurring? What are the chances of what was the other thing? Odd numbers occurring. All that we call it compound numbers. Now, why is this important? This is important because remember I told you that thing, all of our inferential statistics, your t-test, ANOVA, correlation, everything depends upon this thing where you were distinguishing between real findings in your whole population and what might have happened by chance in your small group. Your sampling error and all, I hope you remember. So your sampling, your hypothesis testing, which your statistical analysis, everything, the basic mathematical assumption of that is this basic probability theory. So it is not just a mathematical formula, it is the basis of inferential statistics. So it helps us, scientists or a researcher, make scientific decisions, make logical decisions under conditions of uncertainty, because we genuinely don't know what would the whole group be like. For the whole group, for the whole 5 lakh students in Karnataka, teenagers in Karnataka, we don't know if this is true for all of them, but we are making logical assumptions using mathematics. That is why basic probability theory is important. Thank you very much. I'll share 2 or 3 more videos regarding this.